Let's look at how to find the inverse of a radical function and then find the domain and range for the original function and the inverse. So starting out, remember this is where we use our strategy that we called switch and solve. This is the same strategy that we used for other types of functions. We'll work here for our new radical function. So I'm going to start by writing my function as y equals the square root of 6x minus 8 plus 5. So the switch part of switch and solve is that we're going to take the x and the y and switch them in our function. So I'll now have x equals the square root of 6y minus 8 plus 5. So now we need to solve for y, getting y on one side by itself. We can begin by subtracting 5 on both sides. So x minus 5 is equal to the square root of 6y minus 8. And then to get rid of the square root, we're actually going to square both sides of our equation. The left-hand side, rather than foiling that out, I'm going to go ahead and leave that as x minus 5 squared. We'll look at y here in a moment. And the squaring of the square root gives us 6y minus 8. Adding 8, we have x minus 5 squared plus 8 equals 6y. And then divide everything by 6. So x minus 5 squared divided by 6, we could write that as 1/6 times x minus 5 squared. 8 divided by 6, we could reduce that to the fraction 4/3. So using our inverse notation, our inverse function is 1/6 times x minus 5 squared plus 4/3. If you look at the format of this function, if you think about our quadratic functions, this is a quadratic function in vertex form. So now let's think about domain and range and see what that tells us about these functions. So starting out with our original function. So our original function, f of x, was the square root of 6x minus 8 plus 5. Now recall for a square root function to find the domain, we need to ensure that the expression underneath the radical is always greater than or equal to 0. So adding 8, that means 6x must be greater than or equal to 8. And dividing, and then reduce, x must be greater than or equal to 4/3. So the domain of this square root function goes from 4/3 to infinity. To think about the range, picture your basic square root function and then think about what having the plus 5 has done to that. So it's taken our square root function and it has shifted it up 5 units. So our range for our toolkit function for the square root function normally goes from 0 to infinity. By shifting up 5 units, it will now go from 5 to infinity. You can verify both of those by graphing the original function and taking a look at where that key starting point is located. So now let's think about our inverse function. This is the one that we just found. So f inverse is our 1/6 times x minus 5 squared plus 4/3. To find the domain and range for the inverse function, all we need to do is take the domain and range for our original function and switch them. So for the inverse function, the domain is going to go from 5 to infinity. And the range is going to go from 4/3 to infinity. Think about the graph and why this makes sense. So this function that we have for our inverse function, we know is a parabola. We know that it has a vertex, thinking about our vertex form, at the point 5, 4/3. But we're saying that the domain is just from 5 to infinity. So what that tells us is this is only the right half of the graph. So imagine your parabola with its vertex, and we're chopping it right down the middle, and then we're saying this left side is not there at all. We just have the right-hand side starting from 5 and going to infinity. So by finding the domain and the range of the original function, we can then switch those to find the domain and range of the inverse function, and that tells us that rather than the entire parabola, which would not be a one-to-one function, we're actually only working with the right half of the parabola.